Hi, welcome to Market Board Videos. This video is about electricity basics. So the first thing when you're studying electricity that you have to know, the most fundamental rule, the most important rule, is this rule, which says that in all electrical phenomenon, like repels like and opposite charges attract. So I know that you've heard opposites attract. You've probably heard that almost all of your life, and it especially refers to electricity. So these are three separate pictures. I don't want you to think there's interaction here, but you have two like charges. They want to be as far away from each other as possible. These two are both positive. These two are both negative. In both cases, they want to be as far away from each other as they possibly can. In the middle here, you have a positive and a negative. So they're unlike charges. They're opposite charges. They're going to attract. So that's the fundamental rule for electricity. Like repels like and opposites attract. So where does all this positive and negative stuff come from? Well, it comes from the fact that all matter is made up of atoms, which we've already studied, and all atoms are made up of protons and electrons. Most have neutrons also. We're not worried about the neutrons right now because they're electrically neutral, so we're going to refer to the protons and electrons. Protons, positively charged, electrons, negatively charged. Okay? So if something has an unequal number of protons and electrons, so either it's got more protons than electrons or more electrons than protons, then it's electrically charged, and that makes sense. If it has 7 protons and 7 neutrons, that means it has 7 pluses and 7 minuses, so it's neutral. But what if it has 10 pluses and only 3 minuses? Well, now it's not neutral anymore. Now it has a charge, or it's got 10 negatives, 10 electrons and 5 protons. Again, it's not electrically neutral. Now it has an electrical charge, and that's important when we want to use electricity. So let's talk about one of the rules and kind of put this all together, because the force is not only related to the charges, but it's related to how far apart or how close together they are. It's called Coulomb's law, and basically it says there's some constant, we're going to call it K, and actually it goes more like that, but it doesn't really matter. Q1 and Q2 are the charges on the two individual particles. So we have charge 1, charge 2, and then that's the radius squared. So you take the constant, multiply it by the product of the two charges, and divide by the radius squared, and that tells you how much force it is. Now for our level of physics, we're not worried about all of the calculations associated with that, but we do want to know this, that when the product of the charges go up, the force goes up. This goes up, this goes up. Likewise, if the distance between them, as they get closer and closer and closer together, you have to expect that electrical force is going to be stronger. Kind of like Newton's law of gravitation. When two bodies get closer together, that force gets stronger. So it is here. As the, and I said that backwards, the force gets stronger as they get closer. So as the radius gets bigger, as the radius gets bigger, the force gets smaller. But where I like to think of it is this: as they get closer together, that force gets stronger. So the radius gets smaller, force gets stronger. Which begs the question about conductors and insulators. What's the difference between a conductor and an insulator? And again, I know you've studied this before, so we're not gonna beat it up. I just want to remind you, conductors are materials that electrons can flow very easily through, whereas insulators are materials that electrons cannot flow easily through. Now notice I didn't say electrons can't flow through insulators. I said they can't flow through insulators easily, and that's a big difference. So when you look at an electron movement, if it moves easily, that object is a conductor, and if it moves poorly, that object is an insulator. And the movement of electrons is fundamental to electricity. So you have to have electron movement to have electricity. That's why conductors conduct electricity so much better than insulators do. So how can electrons be transferred from one object to the next? There's two main ways that it can do it. One is through friction and the other is by direct contact, and let me give you an example. You walk across a rug and you shuffle your feet on the rug. You're actually using friction to get some electrons into your body, okay? Then you touch the doorknob, direct contact, those electrons go from you into the doorknob, all right? So through friction or through direct contact, those are the only two ways that you can transfer electrons. There is a thing called induction, which I wanted to call your attention to. And what induction is I've got this charged article. I've got a rod that's charged, and I'm going to bring it near a conducting surface. Now I'm not going to touch that surface. I'm going to bring it near the surface. The electrons in that surface actually move. They don't transfer from one object to the other, but they move within the conducting surface. If you've ever rubbed a balloon on your hair and then moved it away, you'll see that your hair actually moves up. Now, push your hair back down, put the balloon close again. Without touching your hair will move again. The electrons in there actually move, and that's called induction. So grounding then is when you realize, first of all, that electrons are negatively charged and they really, really, really want to be by those protons. They will do whatever it takes to get by the protons, but they're lazy. So they're going to take what we call the path of least resistance, the easiest route. Who wouldn't? Electrons aren't dumb. I take the easiest route too. So electrons want to be near the protons. They're going to take the path of least resistance. It's really wise when you're going to ground something, that you actually give them a roadmap or a path and say, go this way. That's what a lightning rod does. It takes those electrons from the lightning and the thunderstorm and say, hey, instead of coming into my house, follow this into the ground, which is a mass of protons. So grounding is simply allowing those electrons to have, in our opinion and in our view, a safe passage into literally the ground or an object that has an abundance of protons, so that it's electrically neutral. We're going to talk a little bit in the next video about levels and having more electrons and more electrical charge and less electrical charge till everything is even. That's kind of what's happening with grounding. You want to get rid of those excess electrons, and that's how we do it.